Thanks, Joe. I've known Joe for many years. My goal has always been to try and overwhelm the networks he creates, but he keeps one step ahead. So what I want to talk about today is some methods we're developing in the Computation Institute at Argonne National Lab and the University of Chicago that aim to put the tools that we think millions of people need access to in order to engage in discovery and innovation in an era of massive data and high-performance computing. We've just heard a talk on that topic, and I think this builds on that nicely. So one of my, I don't know, he's certainly not my hero, but an interesting fellow nonetheless, George Gilder, 12 years ago, 13 years ago, observed that when networks get as fast as the fastest links within a computer, then we can start to disintegrate a network, our computers over the network. And that concept, which at that time was really only the reality in a few research networks, is what enabled us to undertake grid computing, to start to distribute computing over a network. And nowadays, of course, is what makes cloud computing feasible, which has transformed our lives in so many ways, allows us to stream videos to our homes, to millions or tens of millions of homes around the world, allows us to outsource our mail, our image processing, if we're a company, our customer relationship management functions and so forth. The key concept, though, behind these consumer and business cloud capabilities is that we have, thanks to high-speed networks, reasonably reliable networks, we've managed to outsource a set of mundane activities, managing our snapshots, for example, in ways that allow us to do more interesting, more inspired, more creative things. My interest is in understanding how we might do the same thing for discovery and innovation, where we're not talking about snapshots, but about gigabyte, terabyte, perhaps ultimately petabyte data sets. We're at a time of disruptive change, as many of you have heard here. For example, looking at the cost per human genome, been declining very nicely, roughly at the speed of Moore's law for many years. Suddenly collapsed over the last few years, and perhaps projected to decline yet more precipitously in the immediate future. These and other phenomena mean that the power of discovery that is implicit in large amounts of genomic data, large amounts of manufacturing data, if we're not careful, will become available only to the very small number of people who have access to high-performance computing centers, like, for example, Argonne National Lab, where I work. But I believe we can do better. We can look at what is required, what are the tasks that underpin research, the things that have to be done in order to engage in discovery, and understand how those functions might be delivered to people as easily as Flickr, Gmail, Netflix. How we might build a discovery cloud. So I'm going to say a few words here about what we've been doing at the University of Chicago and Argonne in one very narrow area, looking at research data management, and then at the end I'll say a few words about how we see this expanding to encompass many other aspects of the discovery process. So let's start off saying, what would a Dropbox for science look like? That's the first task that we set ourselves. We observed that Dropbox is used by almost everyone nowadays, the exception of those perhaps who use Box.net and some other similar systems, to exchange data in a way that would have seemed almost magical not very long ago. But scientists working with terabytes of data don't have that convenience. Manufacturing people, as we just heard in the recent talk, when data sets are starting to get up to the half terabyte size, face challenges moving data reliably over networks. We would like to have tools available to us that let us do all these things, but for big data, not just small data as we've become accustomed to in our homes. And so we started a project roughly 3 years ago called Globus Online that aims to take initially these functions of moving, syncing, and sharing data and making it totally seamless, as easy to use as it is for Dropbox. And the result is the system that It's cloud hosted. The logic, the smarts that go into moving data reliably, securely, rapidly, over high-speed networks from one scientific instrument to a remote computing center, from one company's computer center to a remote supercomputing center, as we just heard in the discussion of SMASH, from a genome sequencing center to a cloud facility for analysis, and makes these functions totally automated beneath the covers. So a very mundane task, but one that is increasingly often part of the discovery pipeline. It's been interesting to watch what happened when we made this service available. Within a very small amount of time, we moved to 10,000 registered users, hundreds actually using it on a daily basis. More than 18 petabytes moved so far, close to 1 billion files. Each one of these files moved and terabytes moved, representing some important scientific task that someone is able to undertake. Increasing the performance that's actually achieved over these networks, these magical networks you've been hearing about, often by a factor of 10 or more, because we make it possible for non-experts to move data as fast as experts historically have done. So moving, syncing, sharing data, that's just a first set of essential tasks that have to be undertaken to engage in large-scale discovery in the modern era. But of course, one wants to do much more than simply move, sync, and share data. We want to be able to collect it from diverse locations. Once we've integrated it, we want to be able to analyze it using data analysis tools, collect it, connect it or integrate it with simulation tools, publish it for others to access it, search it, back it up, archive it, annotate it. In the case of science, integrate it into publications. In the case of industry, perhaps integrate it into automatable and repeatable business processes. So these are all tasks that we're undertaking at the moment as we develop out our initial Globus Online service focused simply on automating data sharing activities and data movement activities to something much broader that we call the DiscoveryCloud. My belief is that the future of discovery and innovation will be highly democratized, it will be highly distributed, it will involve people not only in high-end universities and big national labs, but people, citizen scientists, small companies, people in India, in Africa, and even in New Zealand, where I come from originally, all engaged in discovery processes because they have access to the most sophisticated tools, the most important data sets, all hosted not in their home, in their business, in their university, but in large cloud facilities where they can be accessible by any. So in that way, we believe we can accelerate discovery by many more people, and as we've seen with consumer products, reduce the cost of delivering these services dramatically by achieving economies of scale and putting in place machinery that encourage people who are delivering services to improve them over time, via some sort of micropayment mechanism. So those are my remarks. Thank you very much.